future that I leave to my kids, what does that future look like? We're able to produce things without destroying the ecosystem. We probably have healthy and happy humans. We're better at neuroscience. We're better at understanding where mental health issues come from. We've created technology that allow us to be the version of ourselves that we want to be.
I've always been pretty interested in just what are the actual bottlenecks to progress. In an ideal world, scientific progress is basically limited by that individual creativity of scientists. It's not limited by these kind of like solvable, boring things like, did we have the money? Did we have the infrastructure? Did we have the tools? You think of scientific progress as this very unpredictable thing. Okay, but actually we found a part of science where there is predictable ways to unlock the bottlenecks.
Convergent is road mapping what we think could be impactful projects, what we think these fundamental capabilities are that might lead to scaled revolutions. And then we're going out and we're finding founders and we're finding the ideas and we're finding funders and we're putting them together and we're launching these projects and we're making sure that they're successful.
And so the big question is really, how do you organize this level of teamwork that supports very complicated systems engineering, but do that in a context where you're not building a commercial product where there's a huge financial incentive.
Convergent Research have become a center of gravity for a concept called an FRO, a focused research organization. There's a sense of urgency and a hunger to try out new models of how we think about doing science and technology development in a way that is more focused on public good, but also very, very fast.
A focused research organization is a small team structured in a way that's inspired by the way deep tech startups build products, but directed at solving some bottleneck in science or technology without regard to conventional academic or commercial incentives.
Think of it as like a startup-inspired nonprofit R&D project. Something where you take a critical mass of people over a critical mass of time, something like 20 people and $30 to $50 million over 5 to 6 years to create a very clear product. Usually that product is a scientific tool or data set, a public good that other people can use and build on.
The main mission of the Lean FROs develops the Lean Proof Assistant. You can imagine something that will help mathematicians, computer scientists, scientists in general to do proofs.
What does it mean to trust a mathematical statement? What does it mean to trust a program?
We're focused on building computational tools to quantify ocean-based carbon dioxide removal.
What we're doing at EVE is generating a data set. It's a data set that quantifies the activity of FDA-approved drugs against human protein targets.
I have the privilege of working on one of the most impactful problems in science, which is understanding how proteins function in health and how they dysfunction in disease.
11Bio is a nonprofit focused research organization that is building tools that will let us map the brain much faster and much cheaper than is possible today.
So a FRO is able to have a disproportionate impact by unlocking a critical technology or data set that allows everyone else in the more traditional models of carrying out scientific research to do what they do.
How do we approach finding fundamental capabilities? How do we think about gaps in the R&D ecosystem? There are two ways that I think about finding the gaps. So one is that we spend a lot of time talking to leaders in their field and asking them,
what would be the most transformative thing that you can't do in your lab and you can't do in your company? It could be a tool, it could be a system, it could be a data set.
And so when given the opportunity to think about this, they actually come up with really impactful and interesting technologies. Oftentimes these are projects that somebody has been wishing could exist in the world.
I still remember very clearly the initial emails that I received from Adam Marblestone. He had noticed one of our perspectives where we had audaciously outlined our goals for scaling up single-cell proteomics. A decade later, those opportunities have turned out to be quite well-placed.
The other thing that you can do is that you can do a process that we call road mapping, which is to pick a space and pick an outcome and kind of tile the field and understand what is missing. We think about all the physics involved. We do like a scaling exercise and do the math of like, where would this lead if all of these pieces were here?
We knew from the basic research we had been doing in academia that ultrasound was capable of reading brain function. But that was one type of ultrasound and one type of use case. What we didn't know is once we miniaturized those ultrasound transceivers, is the sensitivity going to be high enough? And the physics tell us that, yeah, probably.
There's no rocket science to it. There's no miracle involved in the road mapping. It's just really taking seriously that we could bring together the right combinations of people to try to ground these kind of fundamental capabilities questions in something that's more physics-based and that is trying to go to tractable projects that you might think of them intuitively as very hard projects to get going, might require millions of dollars and very specialized engineering and so on. But you don't need a Nobel Prize to do those things. You just need to organize that.
How do you actually take this idea and how do you actually make it happen in the world? Philanthropists and the federal government don't love funding new entities. And so Convergent is able to play this broker. And we sort of vouch for the work of and the importance of the FRO. We provide this trust in this corporate structure that lets philanthropists and let government fund these science projects. We are a 501c3, we're a nonprofit.
We have accounting and legal and corporate structure.
If we had to figure this out from scratch, it would take a lot longer, and that would defeat the purpose of solving these scientific problems as quickly as possible to have as much impact as possible.
We sit on their boards and we're sort of mentoring them through pivots or changes that they might need to make.
So we spend a lot of time helping our new leaders figure out what those skills are and where to find resources and help in developing them.
We get a lot of that support from things like FROCon. They make me feel less alone. I love coming here because it's a chance to pop my head out of the weeds of the challenges and also the successes of my own FRO and think more about this broader question of what does it look like to have this new model for science? That's a huge idea.
Each of these projects has to get to scale beyond the FRO in terms of its impact.
And so I think that we're about to hit the end of our FRO lifecycle for several of our first projects.
And that will then, I think, contribute a lot to this meta-science question of do people want to iterate on and ultimately kind of reify this model into a more normal way of doing science funding.
So right now we have projects that span neuroscience, BCI, single-cell proteomics, synthetic biology and non-model organisms, climate change and carbon removal.
In some broader way, I think one of the changes we're trying to catalyze is in some ways actually to just get scientists to be a bit more idealistic. What would be the kind of ideal, almost sci-fi way to do my experiment or solve my problem?
You can basically make anything happen in the world and you can create anything in the world. And not everybody knows that. Our projects are successful if they've changed the way that the field works, if they've enabled downstream research, if they've enabled downstream funding. The end goal isn't actually just the product itself, it is the scaled revolution that follows.